Hi everybody, in this video we're going to look at capacitors and charging and discharging. So in the simulator here what we have is a 9 volt cell or battery arrangement, and we're going to switch a capacitor, a 100 microfarad capacitor, in basically connected across the cell via the switch. When we close this switch here, switch 1, the capacitor will charge. This graph here is the voltage, and what will happen is when we first turn the capacitor on, the voltage will climb exponentially. So it will start off slowly, but then it will basically get steeper and steeper. This graph up here on the top right is measuring the current. And what you'll see when we first operate the switch is the current jumps to maximum. So when the switch is first closed, because the capacitor is empty, think of it that it has plenty of space. So basically the doors are wide open and the electrical charge quickly, very, very quickly flows at the maximum rate. Remember that current is charge per second. The unit of charge is the coulomb. So the more coulombs per second we have, the more current we have. So because the capacitor is empty, it can basically pull loads and loads of charge. So the current immediately goes to maximum. However, voltage is the energy behind the charge. So as the capacitor starts to fill up, the voltage across it gets bigger and bigger and bigger. And what you'll notice is this is where the phase shift comes from. So in AC theory we talk about civil. So in a capacitive circuit, the current leads the voltage by 90 degrees. And the reason why that is because when we first switch a capacitor in, it pulls maximum current. So the current is ahead. However, the voltage is at its lowest value. So what we have on the screen here is the second switch is a discharge switch. So when I operate this switch, obviously we charge the capacitor up. By controlling this switch I can charge up. This switch decharges through resistor. Now another interesting thing with capacitor charge times is the capacitor, if I took that resistor out there and just had it connected straight to the battery, when I press the switch, the capacitor will instantly charge. It will be immediately, it will get 9 volts, the current will be very, very high, so you'll get a spike and the voltage will follow quickly after. But by putting a resistor in there, I can actually slow the charge rate down, and I'll show you. So click the button, you can see there now the voltage is climbing exponentially, the current is maximum. But as the capacitor is filling up, it's running out of space, so the current is reducing. As the current reduces, so does the voltage. So what will happen now, note both curves are exponential. So when we get, that'll keep climbing until we get to 9 volts. So there's our 9 volts. So we've got a voltmeter there, we've got 8 point. You can see it's slowly, really slowing down now. So it's still charging, but it's getting slower and slower, and it will keep going. And you can see the arrows there show the direction of current, so the current's going into the capacitor, flowing round, and it's almost full. Now in real world terms you won't get exactly 9 volts, there'll be a little bit of a loss, but that's pretty much fully charged. So if I open that switch now, that capacitor is holding its charge, and it will stay like that for quite a while. That's why you've got to be careful working on circuits, because some circuits, if they are charged and you short those out, you will get electrocuted although the supply is turned off. So what we're going to do now is we're going to discharge the capacitor. So because they're the same value of resistance, it should take exactly the same time. So notice the current's going the other way. So the current is going downwards, negative. That's because the capacitor is now emptying. So when it filled up, the current came in through the top, but now it's giving current away and it's going through the resistor. So we're changing direction. And this is one way in inverters how we make AC using capacitors. So on one cycle the current is leading, so it's in the positive, and on the discharge cycle the current is negative, it flows in the opposite direction. We are about there. Now the actual charge rate, so there's a formula, 5CR. So if you get the capacitor value, times it by the resistor value, and times that by 5, we'll be able to work out the charge rate. And I'm not going to do that in this video because this is just literally just to show you charging and discharging. So what we're going to do now is we're going to change this value, and we'll change this value to I'm going to change it to about 40 kiloohms. Okay, so what you'll see now is it will charge up much quicker. Probably it was 75 before, so you know we're slightly over halfway. So let's hit that button there, and you'll see immediately it's quicker. The current's also, let's drop the current down. So the current, since the voltage is a lot more, it's going even quicker. Yeah, that's because the resistance is less. So there's more current through the resistor and the capacitor is charging up a lot more. And it will keep going until, like I say, so you got there quite quickly. Yeah. Likewise, if I change the value of the capacitor will take longer to charge because it's bigger. It holds more charge. So the more farads we have, the more space we have. So what I'm going to do now is on this particular value here, is we're going to change this, and let's make this really small. So let's make this down to about 10 kiloohms. So are you ready? So we'll turn the charging switch off, and what will happen on here is it'll go the other way. So we'll just move the graph up. Just going to try and move that downwards a little bit there, so we can see a little bit more on what's going on. Okay, so 3, 2, 1, and you can see they're much quicker. Yeah, much quicker there. So charge. The current. Notice the charge rate is a lot longer. And discharge, much quicker. Yeah. So because the resistance is a lot less, the current coming out of the capacitor is higher. So we're actually getting more current. Still discharging. So let's go the other way now. Let's turn the discharge off. Let's make that 400. And this will take a long time. So you'll see there, it's taking a long time to charge up. So what you can do with this, you see, is through some electronic components like a 555 timer that will turn something on when it gets to 2/3 the supply voltage. So the 5 volts is 9, so let's just say when that gets to 6 volts, then that could be used to activate something. And we could change that 400 kiloohm resistor with a potentiometer, so we could make it variable. And you can see not much current at all. The current is very, 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 very slow. That's because the resistance is so high, the resistor is actually opposing the current flow into the capacitor, the charge rate, and the voltage is climbing up really, really slowly. So we'll just hold that there. Obviously, make that 10k much quicker. And if we go the other way now, so let's make that the chart, make that even less resistance. Let's make that 10k. And you can see much quicker. So the current's higher. Okay, and the voltage has climbed up much, much quicker. So that effectively, whoops, is charge. So discharge. charge. So the exponential charge rate there, the voltage, and you can see the current goes from maximum to 0, whereas the voltage goes from 0 to maximum. That is where the phase shift comes from. Okay, another interesting thing to consider is that capacitors block DC signals, so current does not flow through a capacitor, it's the charge that appears across it. So what that means basically is the AC signals can go either side of a capacitor fine, but capacitors block DC signals. So in this scenario here, the left hand side we've got a DC battery. So a battery that's supplying DC. We switch through capacitor into a lamp, and then we have an AC signal again through a switch through capacitor into a lamp. When we close the switch on here, you can see the lamp is flickering backwards and forwards. That's actually what actually happens to lights. They do flicker because they're AC, they're going on and off. You can see the current flows diverting. If I make that up to 5,000 hertz, the simulator doesn't actually show it very well, but that would flash not as much. You wouldn't see the flicker, it would be much more constant. With DC, then nothing happens. The capacitor is fully charged, and once the capacitor is charged, that's it, there's no current flow. So the light isn't actually coming on. So what's happening here is the charge is being detected across the plates of the capacitor. So as the capacitor is basically as the current flows, as the switch is shut, the current senses the opposite side through the capacitor and effectively charges, and then as the supply falls down again, the reverse happens. So the current's actually going back and forth across the charge plates of the capacitor. So just to show you there that capacitors do block DC. DC cannot flow through a capacitor, whereas AC can. So capacitors are also used as filters for blocking out any spikes or any unwanted noise in audio circuits and so on. Okay, so hope you found this interesting. Just a quick look at say charge rates of capacitors and how they work. Okay, thanks for watching. If you like the video, thumbs up. Any comments, or if you need any help with anything, give me a shout. Thanks for watching.